All right, this video is going to cover polynomial equations and inequalities. If you go to Monmouth Academy, it's section 3.8. If you go to UMA, it is section 4.4. All right, so when you see a question ask you to solve, what that's really telling you is to solve for x. Find out what x equals. It also could be saying find the zeros. It could say find the x-intercepts. All of those mean the same thing. So if you have four terms, we're going to do what's called factor by grouping. So the step one with factor by grouping is to see if there's a greatest common factor with any of the terms. This one doesn't have any. Then you want to make sure your degrees are greatest to least. So 3, 2, 1, 0, so they're in the right order. Then we want to make sure our middle term is positive. So we're going to change this to plus -4. Just it visually gives our brain something for later. Then we break it up into two binomials. So we put the first two terms together and we put the last two terms together. Then we find the greatest common factor of each of those parentheses. So if we look at the first one, both of those terms have a greatest common factor of x squared. X cubed divided by x squared is x, and then 3x squared divided by x squared is 3. And then here's why we do this. We want to take out a -4. We do the plus negative, that way it reminds us we have to take out a negative. So -4x divided by -4 is x, and -12 divided by -4 is 3. Now that we've done those, we're going to rewrite this as two binomials. So we take the numbers we pulled out, x squared minus 4, and then we take the parentheses that's the same and slide it down. So we have x squared minus 4, and we have x plus 3 equaling 0. Now we use the zero product property to solve. So x squared minus 4 equals 0. We add 4 to both sides. We get x squared equals 4. Take the square root, so we get x is positive or -2. And then this one, x plus 3 equals 0. Subtract 3 from both sides. We get x equals -3. So we have an exponent of 3. We should have 3 or fewer intercepts. And we have +2, -2, and -3. That's one way to solve. You can solve by graphing. So if I put this equation in my y equals, I'm going to type x cubed plus 23 minus 4x minus 12. That's not 23. Your notes are going to say x squared once I fix them. So then you hit graph. And I'm going to zoom a little more here so you can see. Come on, slide up. X squared plus x cubed plus x squared minus 4x minus 12. So if we look here, we only have one x-intercept. So if I look at that, I do second trace 0. I go to the left. I go to the right. And it tells me my 0 is at 2.5. So I could do it on the calculator. I could draw it out based on that graph. If I zoom out some more, I can find those max and mins, but essentially that's how we do it. Now, if I'm looking at greater than 0 and less than 0, I'm going to put y equals 0 as a line. So above 0 is this piece right here. So the function is greater than 0 when x is greater than 2.5. It's less than 0 when x is less than 2.5. If the bump looked something like that, this whole piece would be greater than 0, and then we'd have two less than 0 pieces. It all depends on what you're looking at. So that's how you can do it by graphing. This one has 3 terms. The degree is an even number, and the term in the middle is half of that, means we can actually solve this with factoring. So if I solve this, A times C, factors of 40, 3, 4, and 10, 4 and negative 10 are going to make negative 40, and when I add them, I get negative 6. Greatest common factor of the corners, multiply up, multiply across, we get x minus 10 and x plus 4. Now, the only difference is, because this is a 4 and a 2, these are going to become squareds. And so we solve from there. X squared minus 10 equals 0. Add 10 to both sides. Take the square root, so we get positive or negative square root of 10. And then we have x squared plus 4 equals 0. Subtract 4 from both sides. Take the square root. Well, the square root of negative 4 is 2i, so we have plus or minus 2i, and that gives us our 4 roots. We have root 10, negative root 10, 2i, and negative 2i. Now, you can leave them listed like I have in the blue boxes, or you can separate them in the green. That's what's up to you. This one here, you can solve, if you get everything on one side, you can do the factor by grouping I showed you in the first one, or you can put it all on one side and try to graph it. That is completely up to you. Pause the video and solve it the way you want. Regardless, we need to get everything on the same side. So 2x cubed minus 3x squared plus 12 equals 8x. Then I'm going to subtract 8x from both sides, and I get 2x cubed minus 3x squared minus 8x plus 12 equals 0. There's no greatest common factor. I put them in order while I was moving them around. You may not have, so you might still have that step. Now I'm going to make the middle positive. Make our two binomials. Here I can take out x squared, and I get 2x minus 3. Here I can take out negative 4, and I get 2x minus 3, which brings down x squared minus 4, 2x minus 3. So to solve those, x squared minus 4 equals 0. And then I take the square root, so I get positive and negative 2. And then the other one, 2x minus 3 equals 0. I'm going to add 3 to both sides, divide by 2. So my third root is 3/2 or 1.5. Here it's saying show 2 is a real solution. So the easiest way to do that is synthetic division, which we talked about in the last section. So we put our coefficients, I don't know what I'm doing here, in an L, 1, 3, negative 11, 2. Put our solution out here, slide this down, 1 times 2, 3 plus 2, 2 times 5, negative 11 plus 10, negative 2 times 1, negative 2 minus 2 is 0. So we've now shown that that's the solution. And where that was cubed, this right here becomes x squared plus 5x minus 1. And then it says find all solutions. So we solve for that. We could try factoring. We could do the quadratic formula. So just as a review, negative 5 plus or minus b squared minus 4ac all over 2a. If you type that in the calculator, I would get, let's see, 5 squared is 25 minus 4, negative 5 plus or minus root 29 over 2. That would be an acceptable answer. If you put it in the calculator, negative 5 plus the square root of 29 divided by 2, you would get 0.19 and negative 5.19. So that would be acceptable either way, depending on what the directions ask. All right, let's look at a couple more. Solve. So in order to solve anything, we need to get rid of our parentheses and do all of that. So even though this is an inequality, we're going to solve it the same way we solve any equation. So I'm going to start by distributing. I get 2x squared minus 2, plus 4x squared minus 2x. Then I want to combine like terms. So we would get 6x squared minus 2x minus 2 is less than 0. We have a greatest common factor of 2. So 3x squared minus x minus 1. Now I'm going to do the quadratic formula with this. So the opposite of b plus or minus b squared minus 4ac all over 2a. If I type that in the calculator, I get 0.77 and negative 0.43. So those are our two solutions. And then we have an inequality. So we're going to test a point in between. Easiest point to test is 0 because we have a positive and a negative. So if I plug 0 in for x, I would get, this ends up being negative 1. So 2 times negative 1. This is times 0, so we end up getting negative 2. Negative 2 is less than 0, so between those works. So my answer is going to be between 0.43 and 0.77. Now let's look at this one. X to the 6th equals 64. Essentially, I could take the 6th root of both sides, but I don't know all of the solutions because I need to be able to get 6. So first, I'm going to subtract 64 from both sides and get x to the 6th minus 64. Now, 64 just happens to be 2 to the 6th. So this is x to the 6th minus 2 to the 6th equals 0. And we can use the rule for difference of squares. Difference of squares is when you have a squared minus b squared. You can break that into a plus b times a minus b. So 6 is the same as 2 times 3. So essentially we're saying x cubed squared minus 2 cubed squared. So I can rewrite that as x cubed minus 2 cubed and x cubed plus 2 cubed. Now, using the sum and difference of cubes, that's another rule that's similar to this. A cubed minus b cubed can be rewritten as a minus b times a squared plus ab plus b squared. So a would be x, b would be 2. So x minus 2 equals x squared minus 2x plus 2 squared, which is 4. And then a cubed plus b cubed just changes this from a plus and a minus. So that becomes x plus 2 and then x squared plus or minus 2x, because those plus and minus change, plus 4. Now we've broken those down all as far as we can, and we solve each piece, making it equal to 0. So x minus 2 equals 0. We would add 2 to both sides, and we get x equals 2. X plus 2 equals 0. We would subtract 2 from both sides and get x equals negative 2. Now I'm going to take this one, and I'm going to do the quadratic formula. So opposite of b plus or minus b squared minus 4ac all over 2a. If I simplify that all out, I end up getting negative 1 plus or minus I root 3. And then the green one would be 2 plus or minus 2 squared minus 4ac all over 2a. And this one becomes positive 1 plus or minus I root 3. So there's 2 purple here, 2 here, and then 2 pink, which gives us a total of 6. All right, let's look at the next problem. A box with an open top is to be constructed from a rectangular 12 by 20 piece of cardboard by cutting equal-sized squares from each quarter and folding up the sides. So we've done one similar to this in a different section. Now, we don't know how big these boxes are, so these are going to be X. So this piece right here is 20 minus 2X, because we're taking away those 2 sections. This piece right here is going to be 12 minus 2X, and this is X. So now we folded our box. We have our three sides. We can find the volume. All right, so our volume of this box is going to be those three parts multiplied together. So 20 minus 2x, 12 minus 2x, and then x. I'm going to FOIL these two. Then I'm going to distribute this x to everything. So x squared, x cubed. Then if I combine like terms, I get 4x cubed minus 64x squared plus 240x. There's my volume equation. Now, for interpreting the point, so if x equals 5, how would I find the volume? So we're saying if this little length right here is 5, how do I find the volume? So I'm just going to plug it in. 4 times 5 cubed minus 64 times 5 squared plus 240 times 5. Plug that right in my calculator. 4 times 5 cubed minus 64 times 5 squared plus 240 times 5. I get 100. So the volume with that's 5 is 100. Now we're going to find the maximum volume. So in order to do that, we want to type our equation in the calculator, hit graph, and we can see, let's try zooming out so we can see our shape here. You got a min down there, so we'll have a max. Let's see, let's try setting our x min to 0. Our x max to 50, and then we know we have a maximum, so let's try 300 and see what happens. We can see a little bump over there. So we know this part doesn't happen because it goes up forever, so we're going to find the max of that little bump. So second trace maximum, move to the left of the bump, hit enter, move to the right of the bump, hit enter, and we see this right here. Our maximum is 2.4, and the volume at that point would be 262.7. So if x is 2.4, our max volume is 262.7 of that box. Now, question D says, what if the volume's 200? So let's go to our y equals, make y2 200. Now we're going to find those two intersection points. So I'm going to make my y minimum a little bit smaller, or my x minimum, maximum, so we can see better. So we know at this point right here, we have a volume of 200. At this point, we have a volume of 200. And at this point, we have a volume of 200. So let's see. Second trace intersect. So the left bound, the right bound. So one intersection is 1.17. Then we do it again. Second trace intersect. Left bound, right bound. We've got 3.9. And then if we do it again, second trace intersect, left bound, right bound. This one we get 10.9. Now, if we go back to our original, x can't be 10.9 because if it's 10, we can't take that out of both sides, so that's too big. So these are the two x's, 1.7 from each side or 3.9 from each side, that would make this box the biggest. Then, less than 200 or more than 200, we're going to use those same numbers. So less than 200 is the part to the left. So from 0 to 1.17, we're under 200. Then from 1.17 to 3.9, that's this top bump here, we're over 200. Then we're negative again from that 3.9 back to wherever it hits 0. So we're going to find that 0 there. Second trace 0, left bound, right bound. And so there I'm getting 6 because, and that's a good thing because half of 12 is 6. So once you do that, you don't have a box. So this would be less than 100. The pink would be more than 100. Just using that graph and my x-intercepts and my max and mins. So now let's do another one. So we have a bunch of data. We have years, which we'll put in L1. We have transactions, which we'll put in L2. So I'm going to go stat edit. If I want to clear out the list, I just go to the top and hit clear. Then I'm going to type 2000, 2002, 2004, 2007, 2012, and then I'm going to type the transactions in billions, 8.3, 13.3, 19.7, 27.9, 52.6. Now this says cubic regression, so I'm going to hit the stat button. I'm going to arrow over to the calc menu, and I'm going to choose number 6, cubic regression. And then we want X list to say L1, Y list to say L2. Hit enter, and we get A 0.006 X cubed plus B, which in this case is minus 35.39 X squared. Let me just get rid of this. And then we're going to do plus C, which is 70,696.16. That's if we enter those years as our number. Now this says if X is years after 2000. So this would be 0, 2, 4, 7, 12. So if I go to my stat edit and I change the years to that, to just the years after 2012 and do my regression again, A and B are the same. Those haven't changed, but now my C, look, it's much prettier. Oh, I guess they have changed a little bit. So now that I've entered those, my equation is going to be much prettier. So following directions is key. 0.02 X cubed minus 0.15 X squared plus 3.09 X plus 8.14. So following the directions of years after 2000, that is our equation. Now it says approximate 2005 and compare it to 22.7 billion. So plug in 5, because 5 is 5 years after 2005. Nope, 2005 is 5 years after 2000. So we would just put 5 in for X and figure out what we get. So 0.02 times 5 cubed minus 0.15 times 5 squared plus 3.09 times 5 plus 8.14, and I get 22.34. So according to the equation, we get 22.34 billion. According to real life, they got 22.7 billion. So while our equation was a little off, it's still a pretty good prediction, meaning this probably matches those points pretty well. And then finally, we want to estimate when it will be 68 billion. So the easiest way to do that is we put our equation in Y1, we put 68 in Y2, and then find our intersection. So Y equals, we're going to clear everything out. We're going to do 0.02 X cubed minus 0.15 X squared plus 3.09x plus 8.14. And then down here, we're going to say 68. Here's my graph. Now I want the intersection. So second trace intersect, left bound, right bound, and we get intersection at 13.1. So 13.1 is 13.1 years after 2000. So in 2013, this is expected to hit 68 billion. So that is the rest of 3.8/4.4. Let me know if you have any questions.